But when the clay at Gubbio is tested for iridium, a rare metal found in the cosmic dust, the results startle everyone. It contains far more than a steady rain of dust from space can explain.
So eventually we came to the firm conclusion that it was an impact from a big chunk of solar system material, either an asteroid or a comet. And that threw up a big cloud of dust, blacked out the light, made it very cold, probably. We weren't sure of that, but a whole lot of terrible things would happen if all that dust came down through the atmosphere.
If Luis Alvarez is right, the dinosaurs met their end in a cosmic collision. Dust thrown high above the atmosphere rapidly circled the Earth. Sunlight was blocked, and day was turned to perpetual night. In the cold and the dark, the dinosaurs and 3/4 of all living species became extinct. As the dust slowly cleared, it formed the clay layer and revealed the desolate face of a devastated Earth. It's an elegant idea, but is it true? The same clay layer has now been found in dozens of sites. But might it have come from volcanic activity here on Earth? Bruce Bohor, a geologist with the U.S. Geological Survey and an authority on volcanic clays, decides to investigate for himself. Bohor knows these rocks at Brownie Butte, Montana, contain pollen and spores from plants that lived with the last of the dinosaurs. Using them as a guide, he quickly unearths the Cretaceous-Tertiary boundary, the time when the dinosaurs disappeared.
The lowest rock that we've exposed here is a dark carbonaceous shale, which is the last of the Cretaceous sediments. We know that from the pollen and spores. On top of that is this pink layer, which is the fallout layer. Over that is a thin coal streak. We know that the plants changed drastically across this boundary here marked by the clay. When we found this clay and dug it out, it looked quite a bit different than the ordinary volcanic ashes that we've been finding. It was harder, it was pinker, it was much finer grained, and these reasons plus the location at the approximate Cretaceous-Tertiary boundary led us to believe that it was something special.
Under an electron microscope, Bohor examines fragments of the clay. Treating them with acid, he notices that particles of quartz remain. The particles contain the clue he is searching for.
Well, this is a normal appearing quartz grain, one that you might see from any sedimentary rock or igneous rock or volcanic. It shows no particular features on the surface. It's fairly smooth. But let's look around in the sample and see what else we can find. Now here we have a quartz grain that shows some unusual features. These grooves were apparently formed by the hydrofluoric acid that we used in etching the grains. We had never seen anything like these features on these quartz grains throughout examination of thousands of rocks of various types. We went to the literature and found out that other people had seen something like this, but only at the sites of known impacts of meteorites upon the Earth or at the sites of nuclear explosions.
So the quartz in the clay was formed by an impact, too. It convinces Bohor that 65 million years ago, an enormous impact shook the Earth. But have these visitors from space devastated the Earth more than once? The story moves on. At the University of Chicago, Jack Sepkowski has found another twist to this intriguing tale. He is compiling a list of the animals that became extinct in the past 250 million years. Carefully, he notes the time when each creature lived and when it died. With over 3,500 families on file, it is the most complete record that exists. Intrigued by the cosmic impact idea, Sepkowski begins his analysis. The results are unexpected. The peaks on the graph reveal a whole series of mass extinctions, some large, some small. More remarkably, they are not random extinctions. They seem to occur in regular cycles, every 26 million years. The pattern of extinctions is a complete surprise to Sepkowski and to his colleague, David Raup.
What we saw was that these didn't appear to be randomly arrayed in time, but rather happening, rather regularly. We said it can't be regular. This must be some sort of statistical fluke. How do we go about testing that? Each one of these events is not an entity unto itself, but part of a regular pattern. So if we're going to understand extinction, we've got to understand each and every one of these extinctions, not just one. The second implication is the implication that we can't consider the biosphere as a closed system that has a history independent of not just the Earth, but the Earth's extraplanetary environment. That if we want to understand the history of life, we have to understand the history of the solar system as well.
Do we live on a planet that is devastated every 26 million years? Many scientists doubt that such cyclic extinctions really occur. Back in Berkeley, Louis Alvarez, like many scientists, is skeptical about these results until he mentions